Welcome back, guys. This is question 2.76, and the statement here is that in an experiment to study the relationship of hypertension and smoking habits, the following data are collected for 180 individuals. Okay, so that is the data for the 180 individuals. Here, H and NH are stand for hypertension and non-hypertension, which you can see that this is H, this is NH. If one of these individuals are selected random, find the probability that the person is A, experiencing hypertension, given that the person is a heavy smoker. Okay, so let me solve it here. So this is the solution. All the given data has been available here. So experiencing hypertension, so what is the condition? So I have to find out the probability that of the person has been experiencing hypertension, given that the person is a heavy smoker. Okay, heavy smoker. I have to find out this. So on the basis of the conditional probability, I have to find the probability that the person has the hypertension and he is a heavy smoker as well. H underscore is S is E for the heavy smoker divided by the probability of the heavy smoker. Okay, so let me see that do I know this value. So person is heavy having hypertension and heavy smoker. Do I know this value? Yes, this is already given, and that is here, that is 30. So 30 divided by 180 is the probability that a person has the hypertension and he is also a heavy smoker, because 30 is the number of the person who are heavy smokers and having the hypertension as well, divided by the total number of the individuals. And now dividing it over the probability of the hypertension, how to find it out? We have to divide it over the person which are heavy smokers. So 30 plus 19. Okay, so this is basically the heavy smoker. So 30 plus 19 is 49. So 49 divided by 180 is the probability that a person is a heavy smoker who has been taken randomly. So these two will cancel out, and here I will get 30 divided by 49, and that is what, that is the solution of part A. Okay. So similarly, now probability of a non-smoker, given that the person is experiencing a non-hypertension. So what do I have to find out? I have to find out the probability that a person is a non-smoker. Okay, given that the person experiencing no hypertension. So no hypertension, this one, and it is the person is non-smoker and he hasn't have any hypertension, divided by the probability of no hypertension. Okay, so now putting these values, uh, do we know the value that person is non-smoker and he doesn't have any hypertension? Yes, this is given, and this is here 48. So 48 divided by the total number of individuals, which are 180. Here is the probability, and the probability that a person is non-hypertensive, yes, that is also given. And how can we find it out? That would be 48 plus 26 plus 19, and that would be the 74 plus 19 is 93 divided by 180. These two will cancel out, and at the end I will get 48 divided by 93, and that is basically the answer of part B. So that's it for today, and I will see you with some more interesting stuff in our upcoming video. See you soon. Welcome back, guys. This is question 2.77, and the statement it has is, in the senior year of a high school graduating class of 100 students. Okay, so with this statement we are also going to write the given data here as well. Okay, so that is basically a given data. Okay, and in given data the total number of students n are 100 in number. Okay, 42 studied mathematics. So mathematics is studied by 42 students. Okay, similar 68 studied psychology. This is P. So 68 studied psychology, 54 studied history. History is represented by age, and that is 54. Um, 22 studied both mathematics and history. So let me write it here. So mathematics and history. Let me write and with this intersection symbol. Mathematics and history is studied by 22. Okay, 22 students. Okay. Similarly, 25 studied both mathematics and psychology. Mathematics and psychology studied by 25. Okay, 7 studied history, but neither mathematics or psychology. So here 7 studied history, but neither mathematics nor psychology. So history and neither mathematics. So this is complement and nor psychology. Okay, so nor psychology. So complement here as well. So this is 7. Okay, and 10 studied all 3 subjects. Okay, so 3 subjects are mathematics and psychology and history. These are how much? These are 10 in number, and the last one is that A did not take any of the 3. Okay, so they have neither taken mathematics nor psychology nor history, and these are basically 8 in number. So this is the given data which I have basically written in the form of the notations which are usually used in the probability and statistics. So what do I have to find out? Randomly select a student from the class and find the probabilities of the following events. So these are the events which are A and B. A person enrolled in psychology takes all 3 subjects. Okay, I have to find the probability that a person is enrolled in psychology who has taken all 3 subjects. Okay, so here I have to find out what. So let me write the solution of it here, and here I have to find out the probability that a person has been enrolled in all 3 subjects. So which are these 3 subjects? These are mathematics and psychology and history, such that he has opted for what? He has opted for psychology. Okay, so he has taken psychology, and the probability that after taking psychology, he has also been enrolled in all these 3 subjects. So by using the conditional probability, it would be probability of M and P and H, okay, divided by the probability that he would be in psychology. Okay, so let me write their values. So probability that he would be in all these 3 subjects would be here, that is 10 divided by the total number of the students, which are 100. So 10 divided by 100, I will get here, divided by the probability that he will opt for the psychology would be how much? That would be the number of students who have taken the psychology. These are 68 divided by the total number of students. This is 100. So these two will cancel out, and here I will get 10 divided by 68, or simplifying it, I will get 5 divided by 34, and that is basically the solution of part A of our question. Similarly, now solving part B of it. What is it given? A person not taking psychology is taking both history and mathematics. Okay, so I have to find out the probability that he has opted for history and mathematics, given that he is not taking this psychology. Okay, so what would it be? So here, by using the conditional probability, I have to find out the probability of taking history and mathematics and not psychology, divided by the probability that he is not taking the psychology. Okay, so here I have to find, as I don't know these probabilities, you can see here that these probabilities are not given, but I know the probability that I have this mathematics and history, and also the probability that these three would be taken. So therefore I have to subtract this value from the value that he will take mathematics and history. So therefore I have to write here 22, and from it I have to subtract this 10 that he has taken all three subjects, divided by the probability of not taking the psychology. Here I don't, again I don't know the value here. So here I know the value that he has taken the psychology, and the people who did not taken psychology would be the total number of people minus the people who has taken psychology as a subject, and these are here given, which are 60. Okay. So now finding the probability of it, what would I get? Here I will get 12 divided by, here it would be 100 minus 68 is 32, which will ultimately give me 3 divided by 8, and that is basically the solution of part B, okay, which is 3 divided by 8. Let me also write it here. So it would be 3 divided by 8. So I hope you have understood the underlying concept, that if certain probabilities are not given, how to find them out? We have to write the total number of elements or the total number of people who has taken the certain subject minus the people who has not taken that subject, and from that I will get the answer which we. So that's it for today, in which we have solved question 2.77, and I will see you with some more interesting stuff in our upcoming video. See you soon. Welcome back guys, this is question 2.78, and the statement here is that a manufacturer of a flu vaccine is concerned about the quality of its flu serum. Batches of serum are processed by 3 different departments having rejection rate of 0.10, 0.08 and 0.12 respectively. Okay, so let me write here the given data first. Okay, and the rejection rates for different departments, which are, let me have here department A, B, C. So probability of the rejection of department A is how much? That is 0.10. The rejection probability of department B is, that is 0.08, and the rejection probability of C is how much? That is 0.12. So these are the rejection probabilities, and on the basis of it I can also find out the acceptance probabilities as well. So probability of acceptance of A would be how much? That would be 1 minus 0.10, so that would be 0.90. For the department B, the acceptance would be what? That would be 1 minus 0.08, so that would be 0.92, and the acceptance probability for C would be 1 minus 0.12, so that would be 0.80. Okay, so these are the acceptance probability. On the basis of it, let me solve the question, and here the inspections by the 3 departments are sequential and independent. So in part A, what is the probability that a batch of serum survives the first department inspection but is rejected by the second department? Okay, so in part A I have to find the probability that A accepts the serum while B rejects. Okay, so how to find them out? Do we know the acceptance probability of A? Yes, we know. Do we know the rejection probability B? Yes, we know. So let me write the acceptance probability of A. So that is 0.90, and rejection probability of B is 0.08, which are given here. Let me multiply them, and that would be 0.072. Okay, so that is basically the solution of part A. Similarly, now we have to find out the probability that a batch of serum is rejected by the third department. So it means that the two departments will accept it. So C will reject it. In that case, A has to accept it, B will accept it as well, while C will reject it. Okay, so C will reject it. Now writing their probabilities, the acceptance probability of A is already calculated, and that is 0.90. The acceptance probability of B is 0.92, while the rejection probability of C is given, and that is 0.12. So 0.12. So now we have to multiply them together, and after multiplying it, I will get 0.099. Okay. So that is what? That is the probability that the other two departments will reject it. The other two departments will accept it, while department C will reject it, and that is obtained by multiplying the probabilities of the acceptance of the first two departments, while the rejection probability of C is multiplied with the acceptance probability of the two departments, and from it I will get this rejection probability. So that's it for today, and I will be see you with some more interesting stuff in our upcoming video. See you soon. Welcome back, guys. This is question 2.79, and the statement it has is in USA Today, dated September 5, 1996, the results of a survey involving the use of sleepwear while traveling were listed as follows. Okay, so these sleepwear were for male, female, and total probabilities of them are also given here. Okay, these are underwear, nightgown, nothing, pajamas, t-shirt, and others. So on the basis of it, what do we have to find out? What is the probability that a traveler is a female who sleeps in the nude? Okay, so the solution it has is, this is a solution, and solution of part A is I have to find the probability that female who sleeps nude or in nothing. Okay, so in the table, let me search for them. So the female column is this one, while the nothing row is this one. This is for the nude. So here we can see that that is basically the entry which it basically crosses. Okay, so now the probability it has is 0.018, and that is basically the solution of part A which we wanted to find. Okay, so that is the solution of part A. Similarly, now what is the probability that a traveler is a male? Okay, so in order to find the probability that a traveler is a male, what do we have to do? We have to see all the probabilities that are concerned with males, and I have to add them together. So therefore I will have to add 0.220, 0.02, 0.160, 0.102. Okay, so let me add them together, and here it would be 0.220 plus 0.002 plus 0.160. Okay, similarly after 0.102 plus 0.046, and the last one here is 0.084, and adding them together, what I will get here, by adding them together I will get 0.614. That is basically the solution of part B which I wanted to find out. Okay, so that is the solution of part B. Now in order to find the solution of part C, assuming the traveler is a male, what is the probability that he sleeps in pajamas? Okay, so that is C, and I have to find out the probability that he sleeps in pajamas. Okay, given that person is a male. Okay, so he's a male. So for it I have to use the conditional probability, and on the basis of the conditional probability I have to use that what is the probability that he sleeps in pajamas let me denote it with this P, and for and I am going to use this intersection symbol, and for with it I have to write this male divided by the probability of a male. So that is what we have. So in order to find that he sleeps in pajamas and he is a male, let me consult this table. So if he is a male, this is for the male one, and he sleeps in pajama. This is here. This is this one, this row, while this one is this column. So this is the end. Writing their values here, what I will get here, writing the 0.102, and what is the probability that he is male. This is already calculated uh, here. Okay, so that is 0.614. Okay, so dividing it over here, what I will get here 0.166, and that is what, that is the answer of my question. Now talking about part D of this question, what is the probability that a travel is male if the traveler sleeps in pajamas or a t-shirt? Okay, so now finding the probability that a travel is male if he wears pajamas, okay, or a t-shirt. So for or, let me write this union symbol, and for t-shirt let me write this T. Okay, so using the conditional probability, what do I have to write here? I have to write the probability that he is a male and he wears pajamas and he also wears t-shirt, divided by the probability that he wears pajamas or t-shirt. Okay, so as we know that here it is not possible, because he will either wear pajamas or t-shirts, okay, or he can also wear both of them, but here the data has not been given. So therefore, in order to write them accordingly, what do I have to write here? I can also write it like the probability that he is male and he wears pajamas. Okay, so this is the probability, or he is male and he wears a t-shirt. Okay, this is the overall probability of this stuff, divided by the probability that he wears pajama or he wears t-shirt. So this will be just like here. So let me write here pajama or t-shirts. Okay, now let me write them accordingly, because using the unions here can also be write the probability of male and pajamas plus probability that he is male and wear a t-shirt, okay, divided by the probability that he wears pajamas plus probability that he wears a t-shirt. Okay, so now we have all the data available. If he is male and wear pajamas, so let me see that where this data is. This is written here. If he is male and wears t-shirt, this is available here. Probability that he wears pajama, this is here, and it is also been written here, and probability that he wear t-shirt is also been written here. So let me write these values here. So probability that he's male and wears pajama, so this is now here, and this is 0.102. 0.102. Similarly, the probability that he is male and wears a t-shirt, this is also been given here. This is 0.046. So 0.046, and dividing it over the probabilities which are given. So probability that he wears pajamas, so this is 0.175. Okay, and the probability that he wears a t-shirt, so this is 0.134. Okay, so now adding them and finding the solution of it. So by adding them we will get what? 0.148 divided by 0.309. Okay, and the answer of it would be what? 0.478. Okay, so this is what, this is the solution of this part D, where we have to find out the probability that he is male if the individual is male if he wears pajama or a t-shirt. Okay. So that's it for today, in which we have inferred some information which is asked from us in this question 2.79. If you have any question, you can ask me in the comment box. So see you soon. Welcome back, guys. This is question 2.80. And the statement it has is the probability that an automobile being filled with gasoline also needs an oil change is 0.25. The probability that it needs a new oil filter is 0.40, and the probability that both the oil and the filter need change is 0.14. So before going to solve for different parts of this question, let me first write the given data. So the given data we have here is, let me represent this oil change with this O. Okay, let me write this oil change, and this says for O is for oil change. Okay, and the probability of this oil change is how much? That is 0.25, and the probability for the filter is also given. So therefore let me write this F for the filter change. Okay, and the probability of a filter change is P of F, and that is 0.40. Okay, and the probability that both the oil and a filter need change is 0.14. So therefore now we have to write the probability of both oil and filter change. So therefore again I am going to write this intersection for and probability of O and F is 0.14. Okay. Now what is required? Let me solve it with this color black. Okay, so what do I want to find out? If the oil has to be changed, what is the probability that a new oil filter is needed? So I want to find out the probability of a filter change given that oil has been changed. So therefore now according to the conditional probability, I want to find out the probability of a filter change and oil change divided by the probability of oil change. Okay, all this data has been given to me, so let me put it here and writing this one here. This is already given, this is 0.14. Okay, divided by probability of the oil change, this is 0.25. So calculating it, what I will get here 0.56, and that is basically the probability of a filter change if oil has to be changed. Okay, so that is basically the probability of it. Now in part B, what is it asking us? That if a new oil filter is needed, what is the probability that the oil has to be changed? Now that is basically the, we can see here that here I want to find out the probability of a oil change given that a filter has been changed. Okay, we can see here that these two are basically opposite of each other. So therefore again according to the conditional probability, I have to write the probability of filter change and oil change divided by the probability of a filter change. Now you can see that here we had this probability in the denominator, while here we can see that this one is the denominator. Now putting these values here, again this value is given, and that is 0.14, dividing it over now probability of a filter change, and that is also given, which is 0.40. Using calculator or finding it, what I will get here 0.35, which is basically the solution of part B. Okay, so that's it for today, in which we have seen two scenarios which are completely opposite of each other. Here I want to find out the probability of a filter change if oil has been changed, while here I want to find out the probability of a oil change if filter has already been changed. So I have found out these two values by using the conditional probabilities which are given here. So that's it for today, and I will see you with some more interesting stuff in our upcoming video. See you soon. Welcome back, guys. This is question 2.81, and the statement it has is the probability that a married man watches a certain television show is 0.4. Okay, so the probability of a married man watching television show is 0.4, and also let me write the given data here as well. Okay, so the given data here is this. So the probability of a married man watches television show is 0.4. So let me represent this married man with this M, and the probability it has is 0.4. Okay. Similarly, the probability that a married woman watches the show is 0.5. So let me represent it with W, and this is 0.5. Okay. The probability that a man watches the show given that his wife does is 0.7. So this is basically the probability that a man watches the show given that his wife watches is basically 0.7. Okay, what do we have to find out? Find the probability that. Okay, now we have three options here which I want to find out, so let me write them with this color. And required things here are, okay, so A, I want to find out a married couple watches the show. It means that I want to find out the probability that man and woman both watches the show. I want to find it out. In B, a wife watches the show given that her husband does. So probability of a woman watching the show given that her husband also watches it. And in C, at least one member of a married couple will watch the show. So this is the or statement in which male or female should watch the show. So therefore I have to find out the probability that male or woman will watch the show. Okay, so that these are the things which are required. So now in order to solve them, this is the solution. So in part A, in order to find the probability that man and woman both watches the show, we have to use the conditional probability, and according to which we know that the probability that a man watches a TV show given that woman watches it too is equal to the probability that a man and woman both watches the TV show divided by the probability that a woman watches it. Okay, so now we can see that what do we have to find out? We have to find this value. So therefore multiplying both sides with this probability of W, so multiplying it, what I will get, I will get here probability of man and woman watches a TV show is equal to the probability that a man watches a TV show given that a woman watches it, multiplying it with the probability that a woman watches it. Okay, so now we have both of these values. This value is given here, and also the probability that a woman watches it is also given here. So therefore now 0.7 multiplied by 0.5. Okay, so multiplying them both, what I will get here 0.35, which is the solution of part A of my question. Okay, so that is the solution of part A. Now in order to find the solution of part B, let me remove it. So removing it and finding the solution of part B. Okay, so now in part B, what do I have to find out? I have to find the probability that a woman watches a TV show if a man watches it too. So in order to do this, I have to use the conditional probability, according to which I have this probability that a woman and man both watches a TV show divided by the probability that a man watches it too. Okay, so in previous part of our question, we have found out this probability, which was 0.35. So putting the value here 0.35, and this value is already available here, and that is here, so 0.4. Okay, so dividing 0.35 or this 0.4, what I will get, this is quite high, and that is 0.875, which shows me that there is a very high probability of a woman will watch a TV show if a man watches it too. Okay, so that is the solution of this, which is 87.5%. Okay, so that is the solution of part C. And now moving towards the part C here, what do I have to find out? I have to find out the probability that a man or woman watches a TV show. Okay, so in order to do so, I know the formula, which is probability of man plus probability that a woman watches it minus the probability that man or woman watches the man and woman watches the TV show. Okay, so now let me put their values. I know the value of 8, which is 0.4. Okay, I know the probability of W, that is 0.5, and this is also known, which I found out in part A, and this was 0.35. Okay, so now finding them out and putting them here, what I will get, you will see that the answer of it will be 0.55, and that is that is the solution of part C, which I wanted to find out. Okay, so that is the solution of all the three parts of our question 2.81, and I hope you have understood all the underlying concepts. So I will see you with some more interesting stuff in our upcoming video. See you soon. Welcome back, guys. This is question 2.82, and the statement it has is, for married couples living in a certain suburb, the probability that the husband will vote on a bond referendum is 0.21. Okay, and the probability that the wife will vote on referendum is 0.28, and the probability that both of the husband and the wife will vote is 0.15. Okay, so let me first write this given data over here. So let me first write this given data over here. So this is a given data. Okay, and let me represent husband with H and wife with W. So the probability that a husband will vote, it is given that he will vote is 0.21. Okay, similarly the probability that wife will vote, that is also given, and that is 0.28. Okay, and similarly the probability that both the husband and the wife will vote. Okay, so again you can see that here and is given, so therefore I have to use the intersection symbol. So therefore the probability that the husband and wife will vote, that is basically 0.15. Okay, so on the basis of these statements, what I can write here is that the probability that husband will not vote, that is represented by this H complement, and that would be 1 minus the probability that he will vote, which is 0.21. So 1 minus 0.21, that is how much? That is 0.79. Okay, similarly the probability that a wife will not vote, that is also represented by this complement, and now that would be 1 minus P of W, which would be how much? 1 minus 0.28, so that would be 0.72. Okay, so these are the two statements or the two probabilities which I have deduced from the given data. Okay, so now on the basis of all it, what do we have to find out? We have to find out the required ones. So let me write here the required items. So in A it is written that at least one member of a married couple will vote. Okay, so at least means either a woman or a husband or both of them will vote. So that is basically the case of a union in which husband or wife or both of them should vote. Okay, so this is the required statement for part A of this question. Similarly for part B, what is given here is that a wife will vote given that her husband will vote. Okay, so we have to find the probability that a wife will vote if her husband will also vote. So what do we have to find out? We have to find the probability of a wife voting given that her husband will vote. Okay, we have to find it as well. And part C, it as a husband will vote given that his wife will not vote. Okay, so I want to find out the probability of the voting of a husband if her wife will not vote. Okay, so not is represented by the complement. Okay, so complementing the term this wife, so we have to find this one. Okay, so now all the required data, all the given data is here. Now let me solve it. So this would be the solution we have. So now solving part A, which is probability of H union W. Okay, and we have previously seen that the probability of the unions would be probability that husband will vote plus the probability that wife will vote minus the probability that H and W both will vote. Okay, so now we have all this given data. The probability that husband will vote is here. Okay, 0.21. The probability that wife will vote, that is also given, that is 0.28, minus the probability that husband and wife will vote, this is also given, and that is 0.15. Okay, so now solving it, first of all let me 0.28 minus 0.15, this is 0.13, and 0.13 plus 0.21, that would be 0.34, and this is the probability that husband or wife or both of them will vote. Okay, or any one of them will vote. Okay, so that is what we wanted to find out. Now in finding the part B, or solving for part B here, what do we have to find out? We have to find out the probability that wife will vote given that her husband will vote as well. So probability that wife will vote given that her husband vote, that can be found out by using the conditional probability, and according to the conditional probability, the probability of wife and husband will vote divided by the probability that husband will vote as well. Okay, now we have both of these data, so W and H, that is 0.15. okay, given here, you can see, divided by the probability that husband will vote, this is also given here, and that is 0.21. okay, so now writing it here. Okay, and when I will solve it, I had got 0.71, which is what, which is the probability that wife will vote given that her husband will also vote. Okay, so this is what we have here, this is all the data, and this is what we had to find out. We have solved part A and part B, which were quite easy to find out, and which you can solve by using the conventional formulas which are previously derived. So now in order to solve part C, let me clean it first. So now in part C, what do we have to find out? We have to find the probability that husband will vote given that wife will not vote. So how to find it out? We don't have a data for this one, but to find it out, let me first give you a conceptual overview of this. So if the probability that a husband will vote is this one, okay, this is for the probability that husband will vote. Okay, similarly for the probability that a wife will vote, this is this one. Okay, and both of them has the intersection here, and this intersection is what, this is basically the probability that husband and wife, both of them will vote. Okay, and this is what, this is the probability that husband will vote while wife will not vote. Okay, and similarly this one is which one, this is the probability or the area in which wife will vote while her husband would not vote. Okay, so also let me color them. So this is the green data which I have represented with this one, while the blue area is this one which I have represented, and this one is here. Okay, so now according to the conditional probability, what do we have to find out? We have to, in order to find it out, we should have known the probability that husband will vote and her wife will not vote divided by the probability that wife will not vote. Okay, so now we have this data which is already known, and this is here, but we don't know this one. Okay, so now how to find it out? We know that this is the probability which is already given, and this is here. But in order to find it out, what do we have to do? From this diagram we can very clearly see that in order to find out this area, what do we have to do? This is the overall area, which is probability of the husband, while this area which is in yellow, how can we find it out? By subtracting this intersection area from this one. Okay, so now we can see that this probability that husband will vote and wife will not vote, that would be this overall area minus this one. Okay, so this overall area is probability that husband will vote, and from it I have to subtract this one, that husband and wife will vote. Okay, so now I think it is clear that how can we find out this overall. If we want to find out this one, it would be very easy, because from this overall, which is probability that wife will vote, from it I have to subtract this intersection area, and you will get this one as well. And this concept will be utilized wherever you will need the probabilities of the items like this one or this one as well. Okay, and over it I have to divide this probability that wife will not vote. Okay, so now let me use this one and putting values here. Probability of H is 0.21 minus the probability that H and W, this is also given, and that is 0.15, and dividing it over probability of W complement, and that is also here 0.72. Okay, so now finding it out, I will get 0.06 divided by 0.72, and ultimately I will get how much? That would be 0.083, and that is the solution of that probability that husband will vote while his wife will not vote. Okay, so that is what we have here. This is 0.083, and that is basically the solution of part C, which was somehow trickier because this data was not given and we have to deduce it from the given data. So that's it for today. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. This is question 2.83, and the statement it has is the probability that a vehicle entering the Luray Caverns has Canadian license plate is 0.12. Okay, so let me represent this Canadian license plate with C, and let me write the given data here as well. So given data, okay, such that the probability that the vehicle will have the Canadian license plate will be probability of C, and that is 0.12. Okay, similarly from this we can also find out the probability that the vehicle will not have a Canadian license plate would be 1 minus this P of C, so that would be P C complement, and that would be 1 minus 0.12, which is 0.88. Okay, so this is the probability that a vehicle will not have a Canadian license plate. Similarly, the probability that it is a camper is 0.28. So let me represent this camper with CA. So probability that it is a camper is CA, and this is how much? This is 0.28. Okay, and from it we can also find out the probability that this is not a camper is CA whole complement, and this would be how much? This would be 1 minus 0.28, which is basically 0.72. Okay, so these are the given data which we have here. And similarly, the probability that it is camper with Canadian license plate is 0.09. so what is basically this one? Here we can again see that this is here with, so with is basically the replacement of and, which is the intersection operation. So therefore here we will have a license plate is of Canada, and similarly camper is this one, and that is what? That would be 0.09. Okay, so this is the probability it has. Okay, so now on the basis of this data, what do I have to find out? So let me write here the required data or required results, and those results are basically written here in the form of part A, B, C of this question. So a camper entering the Lorry Caverns has Canadian license plates. So the given thing here is a camper. Okay, so camper. So what is the probability that entering Lure Caverns has a Canadian license plate? So therefore, what do I have to find out? I have to find out the probability that the license plates are Canadians, given that he has entered and is a camper. Okay, similarly in part B we can see here that a vehicle with Canadian license plates entering the Lure Caverns is a camper. Now what is given here? It is given here that the license plate we have is a Canadian. So what do we have to find out? We have to find out that whether he is a camper or not. So we have to find out the probability of CA, given that the license plates are of Canadian, and here we have found out this. And in part C, a vehicle entering the Lure Caverns does not have Canadian plates or is not camper. Okay, so here this is or, and here we can very easily see that this is represented with this union. Okay, so now what do I have to find out? I have to find out that a vehicle entering the Lure Caverns does not have Canadian number plates. Okay, so he has entered and it doesn't have the Canadian number plates, and similarly here or is given and at the end it is not a camper. So therefore we have to write here CA whole complement, and we have to find out these things. Okay, so now the given data and required data has been written here. So now we have to solve it. So this would be the solution. Okay, so solution of part A here, and what do we have to find out? In part A we have to find out the probability that the vehicle has a Canadian license plate, given that it is a camper. So according to the conditional probability, it would be the probability that it is of Canadian and it's a camper divided by the probability that it's a camper. Okay, so now we can very easily see that here this probability has been given. Yes, this is given. Similarly this one is also given. Yes, it is also available here. So let me put these values here, and putting them here I will get 0.09 divided by the 0.28. Okay, so what would we get? We would get here 9 by 28. So simplified answer here would be 0.32. Okay, so now there is a 32% chance that a camper entering the Lure Caverns has a Canadian license plate. Okay, so that is basically the solution of this question. Okay, so this is the solution of part A. And what is part B? We have to find out the probability that a vehicle with Canadian license plate entering the Lure Caverns is a camper. So we have to find out the probability of this camper, given that it has a Canadian license plate. Okay, so again using the conditional probability, so it would be CA and C divided by the probability of this C. Okay, now we have this given here, and we can see that here it doesn't matter whether we write here CA before or C before, because this is the AND operation, and because here we can very easily see that this basically obeys the commutative property. Okay, so this is always similar. So therefore we have to write here the same value, so 0.09, and dividing it over P of C, which is also given 0.12, and here it would be 9 divided by 12, and calculating it we will get 0.75. Okay, so what is this? This is basically the 75% probability that a vehicle with Canadian license plate entering the Lure Caverns is a camper. Okay, so this is quite high. Okay, so this is basically the solution of part B. Part C, we have to find out the probability that it doesn't have a Canadian plates or it is not a camper. So we have to find this one. Okay, this is what we have here, and in order to find it out, we know the formula, and that is basically 1 minus C and CA. Okay, so again we have the probability which is given, this one is here, and let me write it here. It would be 1 minus 0.09, and finding it out here, what would we get? Here we would get 0.91. Okay, so there is a 91% chance that a vehicle entering the Lurie Caverns doesn't have a Canadian plates or is not a camper. Okay, so this is the solution of this part we had found. So that's it for today, in which we have found the solution of different scenarios, and I will see you with some more interesting stuff in our upcoming video. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 2.84, and the statement of this question is the probability that the head of a household is home when a telemarketing representative calls is 0.4. Okay, so with the passage of this question, I am going to write the given data. So the given data here is, this is a given data, and let me represent the head of a household is home with H, so that the probability of the H is 0.4, which is here. And given that the head of the house is home, the probability that goods will be bought from the company is 0.3. Okay, so this is basically the conditional probability, in which the probability that goods will be bought, given that head of a house is home, this is basically 0.3, and here I am representing the goods bought with this GB. Okay, so I hope it is now clear. So now in order to find the probability that the head of the house is home and goods are bought from the company, here we can very easily see that and word has come up, so therefore this and is usually, as I have previously told you, that this is basically calculated or represented by this intersection sign. So what do I have to find out? I have to find out the probability that the head of a house at home and goods are bought. Okay, so I have to find out this one. So now therefore, what is the solution of our question? We can very easily see that the conditional probability has been given to us, so therefore the formula for the conditional probability here is what? So the good bots, given that husband is home or head of a household is home, that is basically the probability that head of a household is home and goods are bought, divided by the probability that the head of a household is home. Okay, so now what is this? This is the formula for the conditional probability. Now in order to find the quantity which is here, we want to find out this one, because this is what we have been found in the required data. So now in order to find it out, multiplying both sides with P of H, and what I will get here, I will get here probability of H and GB is equal to the probability of GB, given that H multiplying it with probability of H. Okay, so now we know the values which are associated with them. This GB given H is given, which is 0.3. Okay, writing it here, and also the probability of H is also already given, that is 0.4. Okay, now multiplying them both, what I will get here, I will get 0.12. So what is this? This is basically the probability that head of a household is home and goods are bought. Okay, so this is what we have here, and this is 0.12, which is here. Okay, so that's it for today, in which we have found out the probability by using the conditional probability statement, and this is also one of the application which we have seen here. Okay, so that's it for today. and I will see you with some more interesting stuff in our upcoming video. See you soon.
Welcome back, guys. This is question 2.85, and the statement it has is the probability that a doctor correctly diagnoses a particular illness is 0.7. Okay, so what is this? Some probability has been given, and let me write the given data here. So in given data, let me represent the correct diagnosis with C such that the probability of the C or correct diagnosis is. So on the basis of it, we can also find out the incorrect diagnosis, which is basically C complement, which is the incorrect diagnosis. And how can we find it out? We can subtract this P of C from 1 and then we can find it out. So let me find the probability of incorrect diagnosis. 1 minus 0.7 is 0.3. Okay, so this is the probability of the incorrect diagnosis. So given that the doctor makes an incorrect diagnosis, so here what is given, the doctor makes an incorrect diagnosis, the probability that the patient files a lawsuit is 0.9. so another conditional probability has been given here is that if a doctor will make an incorrect diagnosis, the probability that the patient will file a lawsuit is 0.9. so what is this probability? This is the probability of a lawsuit with the condition that doctor will make an incorrect diagnosis, which is C complement. So here this is C complement and this is what? This is 0.9. Okay, so all this data has been given. So from the previous questions you have understood that having the correct given data and knowing the required things will solve half of a question. Okay, so here what is required? So what is the probability that the doctor makes an incorrect diagnosis and the patient sues? So again we can see that and has been used here, and wherever we will get this and, there we have to use this intersection. Okay, so therefore now what is the required thing? We have to find the probability that doctor makes an incorrect decision. So he will have to make the incorrect decision and for it, and I have to write this intersection, the patient sues. So for that I have to make this ls, and we have to find the probability of it, which is written here. Okay, so this is what, this is the required thing which we want. Okay, so now in order to solve this question, what do we have to do? This is the solution, which is basically the third step. And here in order to solve this question, let me use the conditional probability. So by using the conditional probability, we have previously seen that we have to find the chain rule for these type of questions, because here we know that probability of a lawsuit, given that a doctor will make an incorrect decision, according to the conditional probability, it would be probability of a lawsuit and an incorrect decision divided by the probability of an incorrect decision. Okay, or incorrect diagnosis. So we have this one, and what do we want to find out here? We have seen in the required data that we want this one, so multiplying both sides with this PC complement. So what will be left with us? On the one side we will have the probability of the lawsuit and the incorrect diagnosis is equal to what? Probability of the lawsuit such that he has made an incorrect decision, multiplying it with the probability of the incorrect diagnosis. Okay. So what is this? Here we can see that this is a very important relationship which is called the chain relationship. Okay, if you want to find the probability of the two related events, what do we have to do? If you want to find out the probability of the first one which is related to the second one, you have to use this formula, and after it you also have to find the probability of that event as well. So the same has been followed here, and now putting their values here, let me put their values, because the probability of it is also given, and this is here 0.9, multiplying it with the probability of C complement, which is 0.3. Okay, so multiplying them, what would we get? We would get here 0.27, which is what? The probability of the LS and C complement, or the probability that the doctor makes an incorrect decision or incorrect diagnosis and the patient sues. Okay, so that is what, that is the required thing or the required
answer which we were finding to solve this question. So that's it for today, in which we have found the chain relationship between two events, and with the passage of time we will talk more about it. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 2.86, and the statement it has is, in 1970 11% of Americans completed 4 years of college. 43% of them were women. Okay, so let me write this given data here from the given year. Okay, so in 1970 11% of Americans completed 4 years of college. Okay, so let me write it here. In 1970 total 11% of American has completed the college years. Okay, so and out of 43% of them were women. Okay, so women out of them were 43%. Okay, and this was what? This was basically the college degree holders. Okay, similarly in 1990 22% of Americans completed 4 years of college. Okay, so in 1990 how many of them completed the college degree? So those were 22%. Okay, and out of them how much of them were women? So those were 53%. Okay, so this is what? This is the given data. Okay, so what we have. So now in order to solve it, let me first write the required data. What does we require? So in part A, given that a person completed 4 years of college in 1970, what is the probability the person was a woman? Okay, so in part A, we have to find out that given that a person completed 4 years of college in 1970. Okay, so this is again a conditional probability in which the condition has been given that a person has completed 4 years of college in 1970. What is the probability that the person was a woman? So we have to find the probability that a person was a woman given that he or she has completed a college degree in 1970. Okay, so this is what we have to find out here. Okay, in part B, what is the probability that a woman finished 4 years of college in 1990? Okay, so we have to find out the probability that a woman finished 4 years of college in 1990. Okay, so in 1990 22% of Americans completed 4 years of college, 53% of them were women. So we have to find out the probability that the women completed the 4 years of education in 1990. Okay, and similarly in C, what is the probability that a man had not finished a college in 1970? Okay, so we have to find out the probability that a man has not finished his college in 1990. So we have to find it out as well. Okay, so these are the required data we have to find out. So now in order to solve them, this is the solution. Okay, and in part A, we can clearly see that this is a conditional probability whatever we have, but here we can also see that it was 1970. Okay, and in 1970 there were 11% who has obtained the college degree, and out of them were 43% women. So this is already given that this is basically the 0.43, but by using it with the conditional probability, we have a formula here. Let me prove it. That how is it? So probability of a woman given that he or she has completed in 1970, and it is equal to the probability that this is a woman and the college degree has been completed in 1970. Okay, divided by the probability that a college degree has been completed in 1970. Okay, so now in order to find out this value, what do we have to do? Here we have the probability that it's a woman that is also been given, and that is here in 1970, and the probability of the completion of the college in 1970, this is also given here, but here it is known that these two quantities, when these are given in the same year, we can multiply them together here as well. So the probability of women in 1970 of passing the college degree multiplying it the passage probability of 70s divided by the probability of a college degree in 70s, that is also given here. So now these two will cancel out, and what would we get here? We would get this thing, okay, which is what? Which is basically this value, okay, and this remaining value here is, let me write this value, and this is in percentage, so let me write in the probability, so it will be 0.43, and this is what? This is the solution of part A, in which if a person has completed 4 years of college in 1970, the probability that the person is woman is 0.43. okay, so that is the solution of part A. In part B, what do we have to find out? What is the probability that a woman finished 4 years of college in 1970? So we have to find the probability of a woman who has completed the college in 1990. okay, so it will be this one. This is the AND condition, and here if a woman has passed, and this is 1990, so this would be like this one. So how can we find it out? We have to find it like the women has passed degree in 90s, multiply it with the probability that a college degree has been passed in 90s. okay, so we can very clearly see that this probability has been given, and this is in 90s here. okay, so this is 0.53 here, so let me write it here, 0.53, and multiplying it with the probability of obtaining the college degree in 1990, that is also given. And how much is this? So if this one is this is here 22%, which is 0.22. okay, so now let me multiply them, so it would be 0.1166. okay, so this is what? This is the solution of part B, what we have here. okay, so this is basically the AND condition which we have found here, and that is the solution of part B. In part C, we have to find out the probability that a man had not finished a college in 1990. This is C, and we have to find out the probability that a man has not completed his degree in 1990, and we can also find it out by finding the probability that a man has finished his degree in 1990 and then subtracting it from 1. okay, so this is what we have. So let me call it equation number 1. okay, now here we can also see that the probability that a person has not completed his degree in 1990 is equal to 1 minus probability that a person has finished his degree, or a man has finished his degree in 1990. okay, probability of 90 multiplied by the probability of the total completion in 1990, and that is how much? That is 22%, which is given here, and that is what? That is basically the probability of passing a college degree in 1990. So let me write them here. So this would be 1 minus, how much is this? This is probability of male passing in 1990. This would be how much? This would be 100 minus this 53. okay, so male here will be 100 minus 53, so it would be 47%. okay, so that would be 0.47. okay, and multiplying it with the probability of passing in 1990, so that is basically 0.22. okay, because this is 22% and this would be 0.22. so now this would be 1 minus 0.47 multiplied by 0.22, so the answer of its multiplication would be 0.1034. okay, so now subtracting it from 1, what would we get? We would get 0.8966. okay, so that is what? That is the probability that a man would not finish his degree or his college degree in 1990. Okay, so that is the solution of part C. So in this question we have seen the solution of three parts of the question 2.86. If you have any question, you can ask in the comment box. See you soon. Welcome back, guys. This is question 2.88, and the statement it has is, before the distribution of a certain statistical software, every fourth compact disk is tested for accuracy. Okay, so every fourth CD has to be tested before the distribution. So therefore, let me write here the given data. So the probability of testing is what? That is 1. Every 4 of them has to be tested. So the probability of a test is 1 over 4, and this is 0.25. Okay, the testing process consists of running 4 independent programs and checking the results. Okay, so therefore we have 4 tests. So the failure rates for the 4 testing programs are respectively 0.01, 0.03, 0.02 and 0.01. Okay, so let me write them as probability of failure in test 1, test 2, test 3 and test 4. And let me write here probability of failure in test 1 is F1, and that is what? That is 0.01. Probability of failure in test 2 is 0.03. Probability of failure in test 3 is 0.02, and probability of failure in test 4 is how much? That is 0.01. So on the basis of it, we can also find out the probability of the success in test 1, and that would be what? That would be probability of the success in test 1, and that would be 1 minus 0.01. So it would be 0.99. Okay, similarly probability of success in test 2, that is 0.97. Probability of success in test 3 is 1 minus 0.02, which is 0.98. Okay, and similarly probability of success in test 4 is 1 minus 0.01, which is 0.99. Okay, so these are the computed ones. On the basis of all this data, what do we have to find out? We have to find out that what is the probability that a CD was tested and failed any test. Okay, so let me solve this question. So this is the solution, and in solving part A of our question, what do we have to find out? We have to find out that the probability that CD was tested and failed any test. Okay, so probability of a failure of any test is equal to 1 minus probability of success in all tests. Okay, so it has to be successful in all tests. If it is not, so the complement of it has to be calculated by subtracting it from 1. So this would be the solution of part A. As we can very clearly see here that all the program tests are independent of each other, so therefore it would be 1 minus probability of the success of all. So it would be probability of S1 and S2 and S3 and S4. Okay, which would be 1 minus probability of the success in S1 multiplied by the probability of the success in S2 multiplied by the probability of success in S3 and multiplying it with the probability of success in S4. Okay, so let me write their values and let me start it here. So it would be probability of a failure would be 1 minus probability of success in S1 is given, and that is 0.99 multiplied by probability of success of S2, that is 0.97 into 0.98, which is 0 probability of success in test 3, and 0.99. Okay. So let me calculate it, and what would I get here? Here I will get 1 minus 0.93. So ultimately I will get 1 minus 0.93 is 0.07. Okay. So the probability of a failure in any one of the test is 0.07, which is the 7%. Okay, so that is the calculated one which we have done, and this is the solution of part A. Now in order to find the solution of part B, let me first remove it. So in part B, we have to find that given that a CD was tested, what is the probability that it failed program 2 or 3? So this is part B, and we have to find the probability that it has failed of program 2 or program 3. So it would be the 1 minus probability of this success in test 2 and test 3. Okay, so here we can again see that these are two independent ones, so therefore it would be 1 minus probability of the success in S2 multiplied by probability of success in test 3. So these two are also given here, and these would be 1 minus 0.97 multiplied by probability of S3, that is 0.98. Okay, so now multiplying them together and then subtracting it from 1, what would I get? I would get here 0.0494. Okay, so this is the probability that a program will fail test 2 or test 3, and this is the solution of what? This is the solution of part B. Okay, so now let me remove it and proceed to the part C. And the statement, it has in a sample of 100, how many CDs would you expect to be rejected? Okay, so we have a total number of samples equal to 100, and a sample or CD would be rejected if it will fail any one of the tests, which are test 1, test 2, test 3, and test 4. So the probability of failing any test is 0.07, and the total number of tests here are 100. So therefore the probability of the failure in any of these tests is 0.07. So multiplying them, what would I get? Here I will get 7. So out of 100, there is a chance that 7 CDs would be rejected. Okay, so this is the solution of part C. And now towards part D, given that a CD was defective, what is the probability that it was tested? Okay, so initially we have seen that every fourth compact disc or CD has to be tested. So therefore I have told you that the probability of test is that 1 out of every fourth CD would have to be tested. So therefore there is a 0.25 chance that it would be tested. Okay, so this is what, if a CD is defective, it will be tested. Okay, so that is the solution of part D, which is also 0.25. So this is the solution of question 2.88, in which we have seen different parts of it which are related to the independence of the events. Okay, so if you have any question, you can ask me in the comment box. See you soon. So this is question 2.89, and the statement of it is, a town has 2 fire engines operating independently. The probability that a specific engine is available when needed is 0.96. Okay. So we have 2 engines, and for the probability of the availability of for each of the engine is 0.96, and both of them are basically independent. Okay, so let me write here first the given data. let me have a first engine A and the second one is B, and the probability of their availability is 0.96. So probability of the available for engine A is 0.96, and similarly for B the probability of availability is also 0.96. So from it we can also find the probability of the unavailability as well, and that would be what, that would be the probability of A complement, okay, and that would be 1 minus probability of A, okay. Similarly for A the probability of the B complement is 1 minus the probability of B. So putting values here, what would we get? Let me remove them here from here. What would we get? The values here are 0.96 and 1 minus 0.96 are 0.04. Similarly here 0.04. Okay. So these are the probabilities and the given data. So what is basically required? So let me here write the required data. Okay. So what is the probability that the neither is available when needed? Okay. So what do we have to find out? That neither A nor B is available when they are needed. So in A we have to find the probability that neither A nor B is available. So to find the nor of them I have to write here this intersection, and this is what, this is the required data. In B, what is the probability that a fire engine is available when needed? So there are basically two fire engines, so the availability of at least one of them is required when needed. Okay, so for it we have to find out the probability of the availability of A or B or any one of them or both of them. So this is what, this is the required in part B. Okay, so now let me solve them. This is the solution, and in solving part A of our question we have here the probability of A complement intersection B complement, and we can very clearly see that as both of the events are independent of each other, so therefore in order to find the intersection of them we can multiply their probabilities as well. Okay, so it can be written like this one. So now let me multiply them because these probabilities are already found out here. So it would be 0.04 multiplied by 0.04. Okay, so it would be 16. Okay, 16 divided by 1 2 3 4. Okay, or it would be 0.0016. Okay, so this is what, this is the probability that neither is available when needed. Okay, so this is basically the solution of part A. Now in order to find the solution of part B, we need to find out the probability that a fire engine is available. Okay, so in order to find the probability of the engine availability, engine is available, so we can also find it out from the probability that none of the engine is available and subtract it from 1. So here we can write 1 minus probability that none is available. Okay, so now we know that in order to find that none is available we have already found out its probability here. So let me write it here, and it would be 1 minus 0.0016. It would be 0.9984. Okay, so this is what, this is the solution of part B, where this one is what, this is the probability that A or B or both of them are available, while what is this, this is here this one. Okay, so that's it for today, in which we have seen the solution of question 2.89. If you have any question you can ask me in the comment box. See you soon.